factors that affect the spread of fire. The three sides of the fire behavior triangle are weather, topography, and fuels. Weather includes wind, temperature, cloudiness, moisture, and air pressure. High temperatures and low humidity cause vegetation to dry and wildfires to burn rapidly. Wind not only moves wildfires across landscapes, but also supply oxygen that can cause fires to grow swiftly. Number 2. Explain spontaneous combustion. Spontaneous combustion is the outbreak of fire without application of heat from an external source. Spontaneous combustion may occur when combustible matter, such as hay or coal, is stored in bulk. It begins with a slow oxidation process, as bacterial fermentation or atmospheric oxidation, under conditions not permitting ready dissipation of heat. Example, in the center of a haystack or a pile of oily rags. Oxidation gradually raises the temperature inside the mass to the point at which a fire starts. Crops are commonly dried before storage or during storage by forced circulation of air to prevent spontaneous combustion by inhibiting fermentation. For the same reason, soft coal is a small size is weighted to suppress aerial oxidation. Explain what is a flashover. A flashover is the near simultaneous ignition of most of the directly exposed combustible material in an enclosed area. When certain organic materials are heated, they undergo thermal decomposition and release flammable gases. Flashovers occurs when the majority of the exposed surfaces in a space are heated to their auto-ignition temperature and emit flammable gases. Flashover normally occurs at 500 degrees Celsius to 932 Fahrenheit for ordinary combustibles, and an incident heat flux at floor level of 20 kilowatts per square meter. An example of flashover is ignition of a piece of furniture in a domestic room. The fire involving the initial piece of furniture can produce a layer of hot smoke which spread across the ceiling in the room. So next, let us define what is backdraft. A backdraft is a dramatic event caused by a fire resulting from rapid reintroduction of oxygen to combustion in an oxygen-depleted environment. For example, by breaking of window or opening of a door to an enclosed space. Also, backdraft present as a serious threat to every firefighter. Next, let us define what is bite back. It is a fatal condition that takes place when the fire resists extinguishment operations and becomes stronger and bigger. There are various groups factors that affect fire behavior, and this includes the type of fuel and its moisture content, the fuel load fire-resistant treatment, the ventilation geometry and in forest fires, the wind direction topography and meteorological condition. Firefighting experiences of bite-back conditions depends much in these factors or combinations thereof. One can observe the violent behavior of fire, especially in the initial contact of water or other cooling agents during firefighting operations. This is due to the disturbance of intense heat by the cooling effect of water. So now let us define what is flash fire. It is a sudden intense fire caused by ignition of mixtures of air and a dispersed flammable substance such as a solid including dust, flammable or combustible liquid such as an aerosol or fine mist. Flammable gas is characterized by high temperature, short duration, and a rapidly moving flame. A flash fire is defined as CGSP. It may occur in an environment where fuel and air become mixed in adequate concentration to combust. A flash fire has a heat flux of approximately 80 kilowatt square meters to a relatively short period of time, typically less than 3 seconds. A flash fire in environments where fuel, typically flammable gas or dust, is mixed with air concentration suitable for combustion. Now let us define what is heat versus temperature. Heat energy in motion from a high temperature entity to a lower temperature entity. Heat is measured in joules temperature. On the other hand, can be defined as a measure in the internal energy of the entity. Temperature is measured in Kelvin Celsius or Fahrenheit. As you can see, the two are linked but not the same. Temperature is the product of heat. It also may be helpful to think of heat as a verb. Heat has ability to do work, but temperature is only used to measure the degree of that work. The more work that is being done or faster the molecules are moving and the movement of the molecules, meaning the heat the higher the temperature. Imagine this, you have a boiling kettle. You place your hand in a tea kettle and it burns your hand. What burns your hand is the temperature or the heat. The heat because the molecules in the boiling water are moving faster than the molecules in your body, increasing the movement of the molecules in your hand high enough to tell your brain that it's not normal. When molecules are moving very quickly, we typically conceptualize this as a meaning. An object is a hat when molecules are moving very slow. We conceptualize this as meaning at an object is cold. Cold is actually absence of heat, so technically, only when there is no movement or heat of the molecules is something actually cold. One reason that we get confused so often are because of terms like hot and cold. Many people think that hot is just another word for heat. After all, they are both start with letter H, and they don't relate to one another. However, hotness is a word when someone is referring to the temperature of an object or a girl they like, but not that holds no scientific weight. So let's talk about heat transfer. We're really talking about here is how energy moves, specifically heat energy, and how it gets from point A to point B, whether it be here on the surface of the earth, up in the atmosphere, or even out in space. Heat transfer occurs really in three ways, and this includes conduction, convection, and radiation. So let's take a look at each one of these. Let's start first with the conduction. Conduction is a heat transfer as a result of molecular contact. So the best way to understand conduction is by thinking about an example. So we have here a metallic spoon and a match. So we are going to light up the match underneath the spoon. Now that we know is that the spoon is going to heat up, not just the part where the match is underneath it, but rather as a whole. The reason this happens is because of conduction. Energy from the flame is causing the molecules within the spoon to vibrate and transfer the energy from here until the whole material is going to heat up. Conduction is going to happen most effectively in solid materials. So let's not forget about convection and radiation. Let's take a look at convection. Convection is a heat transfer through or as a result of density differences. Again, let's light up the match. It's not the best idea to hold your hand above this open flame like this. And that's because a lot of heat energy generated by the flame is gonna rise. Gikan siya diri, tas musaka siya padulong diri. That was convection all about. This is going to occur most effectively within liquids and gases. Finally, let's talk about radiation. Radiation is a heat transfer by wave motion. Let's pull that flame again. I think we know that because of convection, heat is gonna rise, but it's also giving a travels outwards in a forms of waves. Waves of energy or electromagnetic waves. And that's the third type of heat transfer. So, if we look back, we have three types of heat transfer. The convection, conduction, and radiation. And it's important to know the keyword that goes one of each. So for convection, the keyword is density differences. Then for conduction, the keyword is contact. Then lastly for radiation, the keyword is gonna be waves.